Hello YouTube, this is Remington H. I have something new to experiment with today, the MFJ-226 Graphical Antenna Impedance Analyzer. Today I'll be using this to analyze a couple of my HF mobile antennas. I'll attempt to analyze and adjust an antenna I have in the backyard, another HF mobile antenna that I use with RTL SDR. And I'll actually attempt to analyze a couple of 2-meter handheld rubber ducky antennas. So stay tuned. The first antenna I'm going to look at is a 40-meter ham stick. I believe this is a Workman brand ham stick, and I've done quite a bit of adjustment to it with SWR watt meters and the old SARC 100 that I have. And we're going to see how it looks on the MFJ-226 with and without matching using the MFJ-909 capacitive antenna matcher. I have the antenna analyzer connected to the out port of my MFJ-909. Currently it's in bypass mode. I'm going to press the boot button to turn it on. And I'm going to go ahead and do the sweep frequency plot function. I'm going to set the start and end frequencies. I think I'll start at around 7 megahertz. Let's try that. And we'll stop at 8 megahertz. I think I'll adjust the sweep. Actually, I'll adjust the Y scale to 10. That should give us a good indication of what this antenna is doing. This antenna does require matching. From what I've seen, most 40-meter mobile antennas do. That's at 7 megahertz. And that's pretty much what I expected based on how I trimmed it. Shows about 3:1 SWR on both the MFJ-929's SWR meter and my Radio Shack watt meter SWR meter. Let's try another function, and we'll try reactance. Interesting. This is what it looks like using the Smith chart function. I'm going to go ahead and switch my matcher to what I found to be the best match point, and that's 360 picofarads. Let's see what that looks like. That's very close to what I've been seeing on my MFJ-929. It's been pretty well established that here in my driveway next to another vehicle is not the most optimum place to check SWR, so this actually will go down if I'm in a more open area or on the open road. And this is the reactance. This is the antenna's SWR sweep plot with 470 picofarads selected on the MFJ-909. This might be something worth taking a look at when I'm operating. This is the 20-meter ham stick with no matching. Start frequency is 14 megahertz, stop frequency is 15 megahertz. And this pretty closely aligns with what I've noticed my SWR is using the MFJ-929 and my rig's built-in SWR meter. Let's go ahead and take a look at what the reactance sweep chart looks like. Not bad, although from what I've been able to read, this does indicate quite a bit of loss because a shortened vertical loaded antenna should have lower resistance when you're at low reactance. This is disconcerting, but these are the measurements that an analyzer like this allows you to take to give you an idea of the overview of your antenna, how it's performing and its efficiency, in an easy to read chart. Okay, we're in my backyard. This is a HVT-600 from OPEC. It was my first HF antenna on my vehicle. I bought it a year or so ago. Although it worked, I never could tune it to resonance. Let's go ahead and take a look at what this antenna is actually doing. Okay, I currently have it connected now to the MFJ-226. The MFJ-226 has an N connector on the top, and it comes with an N connector to SO239 adapter. Let's go ahead and press the boot button. And first I'm going to do a single frequency, which is traditionally what we see with typical analyzers. Seems to be resonant actually around 12.79 megahertz. I do have several radials connected to the base of the antenna here in my backyard. Okay, let's go ahead and do a sweep. I'm going to go ahead and select the start and beginning frequency. So maybe, I don't know, 11 megahertz. And we'll stop at, say, 16. Now we can see a graph of the SWR, and I can scroll down and see where the resonant points are. It looks like about 12.785 and also about 15.563. Now I can't lengthen it any further, so all I can do is shorten it. We want it to be resonant somewhere around, 214, 253 would be good. So I'm going to go ahead and shorten it a bit and see what happens. Okay, I've shortened it about 5 inches. I understand that generally for any band, it's about 100 kilohertz per inch of adjustment in your antenna. So I'm sort of following that, but let's go ahead and see where we're now, what the new resonant points are. One thing I didn't expect was that I don't have to re-scan once I make an adjustment. This analyzer monitors in real time. I adjusted it another 4 or 5 inches. Let's see where we're at now. Definitely getting closer. Closer yet. I'm pretty amazed. I have never been able to get this antenna to tune properly when I select the appropriate taps using the jumper. It is currently tapped in the 20-meter portion of the coil, and it looks like I've been able to get a nice low SWR, at least according to this, at 14.254 megahertz. Just for fun, since this meter can do 2 meters as well, up to 230 megahertz, I wanted to see about analyzing my handheld antennas that go on my handheld radios. This antenna came with this TDX1 radio. I now have a aftermarket longer whip attached to it, but I just wanted to get an idea of if it's possible to measure antennas like this. Now I understand the grounding plane is not going to be correct here. I do notice that when I touch the meter or put my hand near it, it does affect the SWR. So I don't know, maybe the handheld radios have a way of dealing with that. But in any event, what I'm going to do is assume that the lowest I can possibly get it is the SWR, correct SWR for the antenna. And it looks like this one's, somewhere around 1.6, 1.65 at 144 megahertz. Let's try a different one. This is a Nagoya NA-771 that I bought, I believe from Amazon. I tried real hard to avoid any knockoffs, and I think this one's authentic. Let's go ahead and give it a try. This is the lowest SWR I've been able to get, roughly, based on my proximity to the analyzer and the grounding issues of trying to do this. But actually, it doesn't look too bad. This is a Diamond SRJ77CA that, if I remember correctly, I bought at a local ham shop before they folded here in Austin. I have a feeling this is a knockoff. I never got very good signal reports when I used this antenna on my Baofeng UV82. Let's see what it's doing. By the way, I'm connecting these with N to SMA adapters that I purchased. Okay, this is sort of what I expected. I've tried some different methods of trying to reduce the SWR by moving the analyzer around and putting my hand over it and trying to, create a ground plane that it's expecting. The lowest I've seen it drop briefly is, like you saw there, to about 1.8 to 1 SWR. Guess I won't be using that antenna. So far, I've been impressed with the overall quality and accuracy and usability of this graphical impedance analyzer. The MFJ-226 is well constructed. It has a hefty feel in the hand. It doesn't feel cheap. The buttons work really well. They're very easy to press. The menu system is very intuitive. There's no function menus on the buttons, so I was able to get right into using it. The manual is well written, makes sense. I look forward to learning more about its capabilities. I don't think it's a bad idea for a new ham to get an advanced meter like this. It will force you to really truly learn and understand all about how antennas work and why they work. So as an educational tool, it's something definitely to consider. Okay, I'll say 7.3 and stay tuned for additional videos about the MFJ-226 graphical network analyzer.